Welcome to today's lesson on zeros and quadratic functions in factored form. All right, let's take a look at the opening exercise. Consider the quadratic function f of x equals x squared minus 2x minus 3. Its graph is shown below. At this time, I'd like you to pause the video and answer parts A, B, and C of the opening exercise. When you're done, please resume the video to check your answers. All right, for part A, what are the zeros of the function or their x values? So to answer this question, you should identify the x-intercepts from the graph and use their x values only for the zeros. For part B, you took the expression x squared minus 2x minus 3 and wrote it in factored form. So using your factoring strategies, that was a trinomial with a leading coefficient of 1. So you had to find a pair of numbers that multiply to be negative 3 but add to be negative 2. That number was negative 3 and 1, which gave you your two factors, x minus 3 and x plus 1. For part C, you substituted your values from part A into your factored form of f of x to show why each must be a zero of our function. So on the left, when x equaled negative 1, your second factor zeroed out to give an overall product of 0, and when x was equal to 3, your first factor zeroed out to give you an overall product of 0. So what part C above shows us is that when a polynomial is in factored form, it is easy to determine the values that will make it 0 by using our zero product property. So the last few lessons, we have been working with quadratic functions in standard form, like f of x equals x squared minus 2x minus 3. And we've been analyzing the key features of the graph and finding the key features using the algebra. Our focus today will be with quadratic functions in factored form. So I'm going to call this f of x down here. And we're going to look at the main key feature of zeros. So another way I could write this then is f of negative 1 equals 0 and f of 3 equals 0. So there is a big relationship between the factors and the zeros of the polynomial. At this time, using the highlighted portions from above, what do you think the relationship is between the factors and the zeros? All right, hopefully you're noticing that the factors and the zeros are the same number, but opposite signs. So in that example on the left, my factor was x plus 1, the 0 was negative 1, same number, opposite sign. That second example, the factor x minus 3 and the 0 of 3, same number, opposite signs. All right, at this time, we're going to look at really 4 big ideas related to this relationship between the factors and the 0. So let's look at big idea number 1. If you know the factors of a function, you can identify the zeros of the function algebraically and the x-intercepts of the function graphically. So let's look at exercise number 1. This was a multiple choice question on an old Regents exam. Which function has zeros of negative 4 and 2? Go ahead and take a look at the 4 answer options, see what you notice. So hopefully you notice 2 are functions in standard form and 2 are the graphs of a quadratic function. So in order to answer this question, we want to find the zeros of all the answer choices. So in option number 1, we can't easily tell the zeros from standard form, so we're going to rewrite it in factored form. All right, so we've got to find a pair of numbers that multiply to be negative 8 and add to be 7. Pair of numbers would be 8 and negative 1. And we now know if we know the factors, we can quickly come up with the zeros using the same number opposite sign. So my factor has a positive 8, so my 0 is negative 8. My factor has a negative 1, so my 0 is positive 1, which does not match the zeros in the question, not our answer. In number 2, you've got the graph of a quadratic. We're going to identify the x-intercepts. So our zeros are our x values from our x-intercepts. So that would be x equals -2 and x equals 4, which is not our answer. At this time, I'd like you to pause the video and find the zeros of answer choices 3 and 4. Resume the video to check your answers. All right, in answer choice number 3, the factored form is x minus 8, x plus 1, giving you zeros of 8 and -1. Not the correct answer. Answer option number 4 is the correct answer. X-intercepts of -4 and 2, 0, giving us our zeros of -4 and 2. Now, before we go on, I want to review some important vocabulary that is associated with polynomials. So in this chapter, you've heard the word roots a bunch, solutions a bunch, zeros a bunch, and x-intercepts a bunch. Now, those 4 terms are essentially asking or talking about the same thing. They just stem from different representations of quadratics. So in that first one, I have a quadratic expression. Technically, expressions have roots. In that second one, I have a quadratic equation. Technically, equations have solutions. In that third one, I've got a function. Functions technically have zeros. And in that last one, I have a graph, and graphs have x-intercepts. So these are all very related, and it's very easy to go in between the different representations to see that they're essentially asking you for the same thing. I could take an expression and set it equal to 0 to create an equation. I could take a function and plug in 0 in for f of x and get an equation. I could take a function and graph all the x, y ordered pairs to create a graph. So really the only big difference is the way in which you write the answers. So roots, solutions, and zeros would be asking for x values only. And for x-intercepts, you should be identifying x, y ordered pairs. At this time, I'd like to formally define what a factored form of a quadratic function is. That would be when a function is of the form f of x equals a factor a times a factor x minus r sub 1 times a factor x minus r sub 2. A cannot equal 0, and r sub 1 and r sub 2 would be representing the zeros of the function. So if I give you a specific example, we could go back to the opening exercise. We had f of x equaled x minus 3 times x plus 1, and it had zeros of 3 and -1. So when you're subtracting in the factor, your 0 is positive 3. When you're adding in the factor, your 0 is -1. All right, let's look at the second big idea, which says if you know the zeros of a function, you can work backwards using the zero product property to find a factored form of the function. And this is kind of really powerful. So it allows us to write the equations for the graphs of quadratics. You wrote equations for other functions from graphs. Linear, you needed the slope and the y-intercept. Piecewise, you would need both the slope and y-intercept of all the pieces. Exponential functions, you needed the y-intercept and the growth or multiplying factor. So now we'll look at how the zeros allow us to write the function of a quadratic. So exercise number 2, what is the factored form of the graph on the right? So there we've got the graph of a quadratic function. So this is kind of broken down into 3 steps. Step number 1, find the zeros. All right, so based on our x-intercepts, we have zeros of 2 and 7. Now at this time, you might even be able to write the factored form already, but we're kind of breaking it into steps. All right, so we're going to take those equations from above and we're going to set them equal to 0 to create the factors. All right, so I'm going to call this some function f of x, where my first factor is x minus 2 and my second factor is x minus 7. Notice, same number but opposite sign of the zeros. We'll now look at big idea number 3. So working backwards from zeros like we did in exercise number 2 creates a function, but we have to consider that there are other functions that will also have those same zeros. So in exercise number 3, we've got the quadratic h of x equals 3x squared minus 27x plus 42. It has the same zeros as the graph above. We're going to write it in factor form to see what we notice. So going through my factoring strategies, I notice there's a GCF of 3. We'll pull that out. We'll then factor that trinomial, finding a pair of numbers that multiply to be 14 but add to be negative 9. That pair of numbers is negative 2 and 7. So comparing the two factored forms of h of x and f of x from up above, we see that both of those functions would have the same zeros. So you might be saying to yourself then, how do I know if my factored form actually matches the graph? So the emphasis in our course is you just have to create possible functions based on the zeros. You'll learn additional strategies for creating functions from a graph in Algebra 2 for the more difficult cases when there would be a GCF as well. So you might also be wondering then what effect that GCF has. If you were to plug both f of x and h of x in the calculator, you'll notice they share the same zeros, but some of their other key features are different. You will see they have different y-intercepts and a different vertex. Again, the emphasis in Algebra 1 is to create possible functions that match the zeros. The last big idea that we're going to look at is that the connection between our factors of a function and the zeros works for quadratics, but we can also extend it to polynomials of higher degrees. So a quadratic function is a polynomial of degree 2, but what about polynomials of degree 3, 4, etc.? So let's look at exercise number 4. Again, this was an old Regents exam question. It says a polynomial function is graphed on the right. Which function could represent its graph? So taking a look at the graph, I notice it is not a quadratic since it doesn't have that characteristic U-parabola shape. I take a look at the answer choices. I see they're all functions in factored form, and I notice they all have two factors. All right, so let's start with the graph and let's identify the zeros. All right, there are 3 x-intercepts, which mean there are 3 zeros of negative 2, 1, and 2. All right, so now we have a problem since we've got 3 zeros, but the answer choices only have 2 factors. So let's go through and see if we can eliminate any of the answer choices. So number 1, there's a factor of x plus 1. I can eliminate that choice since one of our zeros is positive 1. That is both the same number and same sign. Answer option number 2, I see we have a factor x minus 1, which could possibly work. It matches our 0 of 1, so we'll hold on that one. We'll come back to it. Answer option number 3 also has an x minus 1 as a factor, so that's a possibility. We'll come back to that one. And answer option number 4 has a factor of x plus 1, which I can eliminate. So now what we have to do is we have to look at the differences in the 2 answer choices we have left. So I notice looking at those 2 factors, one of them can be factored further. So on answer choice number 3, x squared minus 4 is dots. It's the difference of 2 squares. So I can rewrite this answer choice as x minus 1 times x plus 2 times x minus 2. And there I have my factors that match the graph. So x minus 1 matches my 0 of 1, x plus 2 matches my 0 of negative 2, and x minus 2 matches my 0 of 2. 3 is our correct answer. At this time, if your teacher has left a practice activity, please complete it. Otherwise, this completes your lesson on zeros and quadratic functions in factored form.